Alright, welcome back to mechanical development. Today what we're gonna do is we're gonna see how to make like splines, not really splines, and the function is called swept boss, and it's used for pipes, for cables, for a bunch of different things, and we're gonna make a table with it. So we're going to touch on assemblies, parts, and swept boss. So let's start with a round table. Give it like let's say a meter diameter. We're gonna do some, let's say it's 100 millimeters thick. Nah, that's too much. 80. Let's start with 80. And we're gonna take a fillet and mark these two. Let's say 25 millimeters. That looks okay. Oh yeah, let's say this is our tabletop. We're gonna save this part, and we are going to make an assembly from this part. Also, I hope the fan is not making a lot of noise because it's hot as balls. So when you open an assembly, you saw what I did. I did a new assembly from part. You can take this and you click OK. You should name your parts according to what they should be. And if you do what I just did, this should come here and be fixed in the isometric view. And let's give it some, yeah, we can do all the fancy appearance shit later. All right. So let's make a new part. So now this is the beginning of the design process. Let's say at the top we want to connect to, let's say a mounting bracket is gonna be like a rectangle that's 100 times 50 millimeters, or as you may have heard other people pronounce it. Yeah, that looks okay. Now we are gonna take this plane and we're gonna make something crazy. And let's start with a line. So we're gonna normal to this plane. I picked the plane? Yeah, I did. Right. Why can't I pick? No, wrong plane. I want this plane and I want to make a sketch on top. Cool. Now let's make a line. We take it from here. Let's say we're gonna do something like this, and then it goes down and then it touches the floor. So I'm gonna give it a heights. Later on we can make it smooth and nice and cool, and yeah. So now in order to fully define something, you either need to give it an XY coordinate. So let's say a normal table should be about, if this is the top, if this is the bottom of the plate, we can give it yeah, let's say 750, something like that. You can also do it with splines, but I kind of hate defining splines, and I also hate having underdefined sketches, but we might have to do that. Let's see how it works. SolidWorks. So let's say that this line is 280 and that this line is 200 and this line is overdefined, of course. Just gonna play around with it to see what looks good. This will be an iterative process. And actually, let's do it like this. I said that my table was 750 in diameter, I think, so let's do 750 divided by 2 and then change this to 150. Cool. Now you have one sketch. You keep that sketch over there and you start another sketch and over here. Start a sketch. Let's say we want a circular profile, and that our profile made of, let's say, steel, stainless steel, whatever, is 15 millimeters outer diameter, and in the middle you have another circle that's 8 sounds good. All right, you save this sketch, and now let's see how this looks. Cool. You go here to swept boss base. Now you have 2 lines here. One of them, each one is a sketch. This is the profile which you will choose, and this is the line which the profile will be led upon. And then you click OK, and it looks horrible, but you know, gonna be a process. Let's call it a leg. Now you go to your assembly, table assembly, and here you can click insert component and it will show you what's open, or let's go over here, you go over there, you go to thing, you find where you saved your stuff, and you can click and drop. Now this is free in the air, it's free to be everywhere, right? So what you gotta do is insert something called a mate. A mate tells one face or vertex or edge to connect with something else. So let's say I want to connect this surface or this face with this face, and then I click both of them, and the automatic one is coincident. You can also do parallel, and you can do perpendicular. If you do perpendicular, they will be perpendicular. Amazing. Let's go with coincident. Now depending on how you like to work and how you like to be, and so on and so on, specifically for this assembly, I would say let's go to this part, collapse it, and expand, and pick this lane which is in the middle. Very convenient. We thought this through, and we can either pick this plane and then click mate, and voila, we have this thing here, and we can click OK. Now something that I just saw, let's go back to our part with Control Tab, and let's go to the leg. Let's say we want, and let's go to the hole wizard, and because the screws are going to come from the bottom, we want to have clearance holes. We want to go to Dean and then screw clearance, and let's say we connect it with M10 bolts. We want it through all, and here you can say you want it in a close clearance, normal clearance, or loose clearance. Usually normal, but will depend on what you want to do. You click positions, you choose a plane where you want to put your bolts, your holes, and let's put for here Cool. Now Control 8 gives you the normal to a face, and let's talk a bit about robust design. And this plate will be subject to changes. And you can listen and also look at what I see while I do it, because I'm doing two different things at the same time. We want to define the relations in a way that will be easy for us to change. So I could do this, and then let's say I do this, and you check where you have, yeah. Cool. So you see they're all black. You can go and say, okay, cool, it's fully defined. The dude in the YouTube said you need to fully define your sketches. So here you go. Now I like it to be, let's give it a bit of yeah, let's do 30 here, 80 there, 40 here, and 15, so that it's symmetrical and nice. Now if I go and I change my plate to, and let's say I want now 120, because I saw that the table is really big and this plate is really small, and I want something else. So I changed it to 150, 120, and 60. Let's keep it nice and symmetrical. You see that this thing now, like in German it's called a whole picture, it stayed the same, because the way I, not this, the way I defined the holes was in relations to the middle. Now you need to think what you want to have. Usually for this kind of construction, I would go with, let's do the relations to the outside. Let's say I want, like, these are horizontal, so when I move this, when I don't have this and I move these, they move together, right? Makes it a lot easier. So let's say I want these to be 15 from the left side, and I want these to be symmetrical. Then I want these to be, let's go with 15, 15. It's easy enough. It's fully defined. Now, if I go and I say, oh, I don't like this plate, I want 150 and 75, then it goes with it. It changes with it. The only thing, there's no right or wrong. There's how do the two parts interact in a way that when you change them, they still work and they still make sense. Like, it doesn't make sense for the plate to be bigger and the holes to stay in the middle. Simple enough, you understand, you're a smart person. Now, I don't like this leg thing, so I'm gonna go to this sketch, the sketch that defines the path, and I'm gonna do something that I don't really like, and we're gonna take a spline. Now I'm gonna do like this and that, and oh yeah, that looks amazing. And that, okay. And I'm just gonna tell it that it's fixed. It's fully defined. I'm not gonna start defining this thing. Now it's telling me that it doesn't know how to do stuff, but it's okay. What is this one? This sketch contains dimensions that didn't exist before. It doesn't know who it is concentric with. Let's put it with, can I pick the origin? Coincident. All right. Yeah, okay, it's ugly, but you know what? Let's go nuts. Let's go and do this thing, you know, like. And this one fix, because And you can, oh my god, this is so ugly. No, I refuse. And let's take this now. And let's see. Still ugly, but what can I say? Alright, so it looks slightly better. So this thing that we started mating is still free in one direction because we told it that the top face is to be on this face, so that it was free in two directions. Then we told it that these two planes are to be coincident, and now we only need to decide how far away we want it from the center. Now, I think it would be nicer if we came here to our plate, went to the bottom side, and started making some cuts. And we connected, let me check for a second. This is the isometric view. Yes, this is the isometric view. We were on the front plane. All right, cool. So let's go here. We want to do this thing here, and we want to draw this rectangle, and let's say it's 150. No, wrong. It's 150 long and it's 75 wide, and it sits here, and these two are horizontal, and the distance between them is, you can also define this distance, it's okay, easier. Let's make 50. So the center of the leg, the foot, the base is gonna sit here at 125. You can add dimensions like this so that you know where things stay. It gives you an error message. You just tell it okay. So I know that the end is 200 millimeters away and the center is 125, and I have 50 millimeters from the closest edge. So I have a fully defined sketch. I close it. Then I go here and I tell it, I think it was 10, and we can go check. Yes. You click this thing, you go to measure, and of course this is off. Yeah, 10 millimeters. Okay. So this will look a bit nicer now because we're going to delete this thing. We're going to delete this thing. And this is going to be free in the air. We're going to click mate. I don't have it defined yet. All right, we're going to click mate, and we're going to click this face and that face, and we're going to say okay, and we are going to click here and there and say okay, and here and there, and we're going to say okay. Cool. Now something to notice. This is exactly 0 on 0. Like there's no manufacturing clearance at all, and this is not a good idea. But just to work on the tools a bit. Now this should go to the bottom because fillets always come at the bottom, and I still don't really like it, so we're gonna do this. And let's say 15 looks nice. And I don't know if you know, but I'm not really following any design points or anything. So we have a slot here, and we are going to do a circular pattern. Now, a circular pattern, instead of me drawing 3 times the same thing, it does it around a circle or along a circle. So you can pick this. You just need to pick an edge. You can also pick this face, I believe, and it will do the same. Yeah, you can also pick a point, but I would rather do it with an edge. The edge will be carried over to whatever we do later. So equal spacing, or you can say instant spacing, which means you can either say I want you to happen every 25 degrees and I want you to happen X times. Of course, if you do equal spacing, you happen along 360 degrees, which is a circle, and then you can tell it I want you to happen 4 times. Look, it's symmetric, beautiful. But we're gonna have 3 times because that's how we are. And I have to create instance, try again, decreasing the number of instances. And features and faces. Yeah, I also want this, and I want, no, that doesn't need to go there. Good. That's why it didn't work, because we wanted to feel it, circle pattern, and you also needed the cut on which it lives. Now, you noticed I did a thing here, which was to move this one from here to the bottom. Your fillets and circular patterns and mirrors and all that, all those things, all those shebangs, they live at the bottom of the tree because reasons. So you always save as isometric view because this is how best, what is it called? Not best behavior. Correct way to do it. I don't remember how to say it. Best practice. So we're gonna take the 15 that we remember from the other thing, and we're gonna put it here. Oh yeah, so beautiful, amazing. And this is the part. Okay, let's go to our assembly. Amazing. Now we want to do the same thing we did with the pattern, the way we did this. We can do it with components. You go to linear component pattern, you click circular pattern, and it's exactly the same thing. Around this curve, you want equal spacing, you want it 3 times, and you want this thing. And ba-bam, you have a table. It almost looks okay, except these things are way too far. So let's fix that real quick. Let's go to our sketch and we remove the fix. It's gonna be a bit challenging. Whoop, whoop. All right, now we take a tangent and we do a bunch of these and we press OK. Oh my god, this is so ugly. It's so ugly. Let's do it again. Yep. Right. Now, can I tell it to be at a distance from here? Let's say if it was 50 divided by 2, 375, so we want it to not be outside the table, right? Let's say 250, yeah, that's about right. And the rest we can fix, no. And then we take the tangents, we take this, and this, and this. So this is 250. We fix everything, including this point, so that it doesn't give us the little minus here, and it's not amazing, but it is what it is. Now we can do a few more things, like we take fillet, we can click this, maybe 2 millimeters, 1.5, 1.75, No, 1.6. Yeah. You know, has to look nice, right? Okay, so now we have table that's about 1/2 meter tall. It's a table for children. And now you want to do the fancy shit. I don't do this very often. I don't usually do this. Oh my god. Let's open appearance library, and let's say I want it to be, you can pick like their predefined textures. So let's go and look, let's look at things. Plastic, is there wood? Is there stone? Brick? A brick table. Organic. Is wood organic? Yeah. Yeah, look at this table. Now these should be black. I don't know why, but I decided that they should be black. Appearance. So let's go to metal, and we take steel. Let's take yeah, it's something like cast steel, not really black. Undo is your friend here, by the way. We go back there. Let's go to, yeah, not steel. Rubber. Let's go to rubber. Now, important, this did not assign a material, it merely assigned an appearance. The way to assign a material is you go here and you pick this thing. You go to edit material, or you pick whatever. Another thing to note, here I define the appearance inside the assembly environment, right? When I go back to the part, it's a normal part with a normal ugly color, ugly texture, and so on. So, you know, if you define it here, any assembly you put it in will be the same color. Same with this tabletop, right? So let's define for this a wood. Woods, it's not Plaza. Let's go with mahogany. It's very heavy and nice, and also looks nice in SolidWorks. Yes. Appearance stay the same. This is not the same as this. It changed. Okay, good. You can also like decide, but anyway. So now if you go to evaluate and you go to mass properties, you will see that this weighs 3.7 kilograms because this is wood. But you can select these and press mass properties, and they also have mass. Amazing. How did they do it? The material is not specified, and somehow it has mass. Interesting. And let's say this is, yeah, let's go with plain carbon steel. Mass properties, suddenly it's 1.5 kilos, which makes a lot of sense. And we go back to our assembly. Hey, so where were we? We changed the material. Now the whole assembly is 4 kilograms, and we are missing screws, which I don't think we need right now, but let's go here and let's go here. This was M24, that's not good. What if I put this here? Aha, bad. And first What was this? 18. Yeah, let's change it. We go to the thing we created in the first video and we change this to M10. Let's give it 10 and let's go here and change it a bit. Instead of 14, I think it is 16 instead of 28. No, it's not. 8. Let's give it 10. Yeah, that almost looks okay. It needs less depth. Instead of 10, let's give it a 7. And we make it shorter because our table was like what, 30. The plate was 10, so let's give it 25. Let's see how it works. So we come back here, we want to rebuild. We have this thing here. By the way, this is sort of a top-down assembly where you put a part and you change it according to what it looks like in the assembly. More on this later. So let's go here, assembly, mate. We don't pick this one, we pick this one first. Then we go under here, let's tell it it's coincidental. And then you pick this one, you tell it mate, you pick this cylindrical face, coexcentric. You can lock the rotation, and more on this later. And you are fully defined. Good. Now we have here 12 holes. Do we want to do this 12 times? We do not. We work smart, not hard. So let's take a pattern driven component. Let's try. Let's take this thing, and this is the driving feature. That's the wrong ass direction. Why is it the wrong direction? Because this can be, let's change the mate. Instead of this one, we take this one. Let's see, pattern driven. This we want to pattern. And we want it over this. Amazing. Does it work? It works. We don't have holes in our table, but it will wait for it later on video. Now, so we connected one bolt and multiply them, and now we can go to our circular pattern. We go here and we tell it we want it 3 times, and in our tree we go and we pick this thing, and now it shows us it wants to do this, and we have all the bolts we need. These are not the correct fasteners for this kind of product, but from your side of things it is exactly the same. So see you next one. I hope you've enjoyed. I hope you learned something. If not, maybe next time. Like, subscribe, share things, comment. Tell me what you want to see. Tell me what you want to hear. Tell me what you're having problems with. And you might get personal tutoring from a person. Me. I mean me. I am the person.